question first. Okay, so specifically, we will be looking at question 8, all right? So for question 8, this reaction is where you have a chromium complex, sorry, reacting with this ligand, PR3. What happens, this is a ligand exchange reaction, okay? 2 separate experiments were carried out. In the first experiment, PR3 was in a large excess and chromium was measured. So this is the graph showing you concentration time graph. Now it doesn't say which concentration, okay? So this graph is just a general axis, okay? General axis for concentration time graph. So you need to label the first curve that you have here is for chromium complex, okay? Because it says PR3 was in large excess and then the chromium complex, the concentration of chromium was measured with time. So that means this graph is showing you how the concentration of chromium complex changes over time. Okay, so CrCO6. I'm gonna label that first. How do I move this? Okay. I'll use blue. Right, next is in the second experiment, the chromium is now in large excess, okay? And the concentration of PR3 was measured with time. So that means we're going to plot another line, okay? Now, bear in mind when the question says draw best fit line, line does not mean a straight line only. It can be a straight line or it can be a curve. So it depends on your points. If you think that it looks better with a curve, you draw a curve, okay? Best fit line does not mean it is a straight line. Best fit line can mean a straight line or a curve. Right, let's start plotting. So at 0, I'm going to change my color so you can see it. At 0, it's 0.01. Okay, it's there. 120 is somewhere here. 0.076246. Okay, and then at 200, it's there. 360. I think it's there. Okay, so I've plotted my points. Now, what do you think? What do you think of your points? Is it a straight line or is it a curve? Straight line, yes, that's right. It's a straight line. So please draw a straight line. That looks like that, okay? That is in fact a straight line. And now you label this graph, it belongs to PR3. So this graph is a little bit different from the graphs that you have encountered in question 4, 9, and 10, okay? Okay, right. Next, use the graphs to determine the order of reaction with respect to chromium and phosphorus. In each case, explain how you arrived at your answer. Okay, if you still remember, for a concentration time graph, okay, the most there's one order that is the most significant, and it's different from the rest. Does anyone remember which one that is? Concentration time graph. So usually they show you the general shape of a concentration time graph, and there's a straight line, there's a curve, and a curve. So this straight line, what does it tell you?
Zero order.
Zero order, okay? A straight line in a concentration time graph is zero order. That's the easiest. The moment you see a straight line, it tells you zero order. Now, why? If we know zero order means the concentration does not change. The change in concentration does not affect the rate, okay? Now, here we have a concentration time. We don't know the rate unless we look at the gradient, okay? And as you know, the gradient of a straight line is the same at any point. Whether I take the gradient here, whether I take the gradient here at this point, or at this point, okay? So at any point of the concentration, my gradient, or as you all know, gradient is rate, okay? So for a zero order, it is a straight line because the the rate stays constant. Okay, so to answer this, you can say PR3 is zero order because it is a straight line and a straight line tells you that it is, the rate is constant. At different temperature, the rate is constant. Are you okay? Can we
Miss,
move on already? Yeah.
Miss, can you repeat the last part?
About the zero order?
Yeah.
Okay, so PR3 is zero order because it is a straight line. Straight line means the rate is constant at any concentration, okay? The rate is constant at any concentration. So if you take the concentration of 0.01, that's the rate. At 0.008, the rate is the same. At 0.004, the rate is also the same. At 0.002, the rate is the same. How do you find the rate? You find the gradient. You draw a, well, you don't have to draw a tangent because it's a straight line. You just find the gradient of the graph. Okay, can I move on now?
Yes.
Okay,
Yes.
next is to find the order of chromium. Okay, the chromium complex. Now there are two ways to determine the order. The first one, I'll teach you the easier one. Okay, now using half-life. All right, I still get some people getting confused with calculating half-life. Now, when you want to find the half-life, so PR3 is done. Okay, so we don't have to worry about PR3 anymore. So we just want to have a look at the graph of the chromium. Okay, now in your question 4, 9, and 10, the exercise that you did before this, most of these graphs have, most of the graphs, there are two curves. Okay, and I don't know, some of you did a really weird calculation for the half-life. You just have to focus on one curve. Take one curve and then do the half-life, okay? Even that, some of you still get confused what a half-life is, okay? Now, even though in your notes it says that half-life is independent of the starting concentration or something like that, okay? Now, since most of you got confused, the easiest way to do it is to start at the starting concentration, which is 0.01. Okay, forget whatever I said about the half-life does not take into account where you start or what your starting point is. Okay, now we're going to start at the initial concentration, which is 0.01. Half-life is the time taken for the concentration to go half. Okay, your concentration goes half, not your time. Your time will not go half. So when your concentration from 0.01, half of that is 0.005. Okay, so you draw a line there, and then the time, right? What you want to read is the time essentially. Okay, that's one half-life. We want to compare at least two. Okay, at least two half-lives, because you want to know if the half-life is constant or increasing. Oh, before I forget to mention, now if you see a curve in a concentration time graph, you cannot assume that it is first order, because it can either be first or second. It's definitely not zero order. Okay, but you cannot just assume, oh, it's a curve, and usually the answers are most likely to be first order. Okay, you have to find and support your answer. Okay, most of these questions want you to support your answer. So even if you say first order, why have you said that it's first order? So saying first order is not enough. Okay, right. Going back to this half-life calculation. So from 0.01, I go to 0.005. Half of that is 0.0025, which is around here. Should have used a different color for this one. Okay. And then you draw the vertical line. You need to extend a little bit. Okay. So this gives you two half-lives already. Okay, two successive half-lives. This is the first T half. And this is the other T half. Now, why do we want to find the half-life? Because if you remember in your notes, the half-life of a first order is constant, okay? And then the half-life for a second order is, let me just double check again before I get it wrong. Increasing, okay? So the half-life of a second order is increasing. So now you want to find the half-life of this concentration time graph of chromium. Is it increasing or is it constant? Now, sometimes you will get like very small difference in number, okay, which they should be constant, right? So I want you to calculate your half-life first. Okay, can I have your answers, please?
700.
700? Any other
For the
answers?
first 690.
700, 690, okay, both are accepted, okay? So 690 and 700, you may think, oh, there's a difference in 10, but actually you can consider them as being more or less constant, almost constant, okay? So given the fact that your half-life is almost constant, what does this tell you about the order of chromium complex?
First order.
First order, yes. So you will write down the order with respect to chromium is 1, or you can say chromium complex is first order. please write down the formula. Don't write down chromium complex. Write down CrCO6, first order, and then to give a reason, because the half-life is constant, which is about 700 second. Okay, use the unit that is given to you in the axis, second. Now, in the previous exercise, where they give you the unit of time in minutes, you can keep that as minutes, okay? You don't have to convert it to seconds, because that would just be an additional step for you. In the exam, you don't want to spend too much time, right? So if the axis is in minute, and I know I always tell you that the unit of time is in second, you just leave your answer in minutes. Okay, you don't have to convert it to second again, because some of you, I saw that you convert it to second, which is fine, which is accepted as well. But some of you did not convert it correctly. Okay, I think you multiply it by 60 instead of dividing it by 60, because the time is actually per second. So that means it goes at the bottom. So if you want to change per minute to per second, you have to divide by 60. Okay, but again, as I said, if this was in the exam, you just use the unit that is given to you in the question, unless the question says otherwise. If the question says leave your answer in per second, then you have to convert it to per second. Okay, in this case, it's already in seconds, so you don't have to worry about changing the units or anything. What's the next question? Oh, the second method that I want to teach you, okay? That's the first method, which is the half-life method. The second method is looking at the effect of concentration and rate, okay? So I'm going to erase this half-life calculation so that you can see. Okay, so the second method is the relationship between concentration versus rate. Okay, what do you know about first order? When you increase the concentration by 2, the rate is also affected by the same amount, directly proportional. Okay, now how do we find concentration versus rate in this graph, in this sort of graph? Now, this is a concentration time graph, and to find the rate, you have to find the gradient. Okay, so to find rate, you have to find the gradient. Now you need to be familiar with this second method as well, because this is what most of you did not do for question 4, 9, and 10, okay? It is essential that you need to know this method as well. Right, so you just need to compare two concentrations. The first concentration, the easiest, is at 0.01. Okay, when your concentration is 0.01, what is the rate? Okay, how do we find the rate then? The rate of a curve is the tangent. So I'm going to change this to a green. Okay, so your tangent has to not pass through, it has to be tangential to t equals to 0. Okay, I hope you know how to draw tangent. And then to find the gradient, now some of you draw like very little small triangle. You know what I like to do? I extend my tangent until it hits the x-axis. It's easier to read. So this point is 0, 0.01, and then this coordinate is 720, 0. So from there, I can find the gradient or the rate really quickly. Okay, so if I do that, 0.01 divided by 720. So I got like 1, 2, 3, 4, 5. 1.38 times 10 to the power of minus 5. Okay, this is what we call the initial rate. Oops. Initial rate of reaction. Okay, that's one. Now I need to compare two, just two. So I find another one. The easiest one is half of that, which is at 0.005, which is at this point. Okay, so I need to draw another tangent because I want to find the rate. 0.005. Now this is method 2, okay, to find the order of chromium. The first method is the easiest, the half-life, but this one, this idea, this concept, you need this for the previous question. In this question, you can just get away with half-life, which is fine. Okay, so the other tangent that I want to draw is this. It has to touch just that point. Okay, so I'm going to try my best. Okay, that's my tangent for the point 0.005. Now I'll change that point to a different color. This point, okay? I'll change this to pink. Okay, so now my tangent will have to just touch that. Okay, then I extend my line. Okay, so I can't extend it to x-axis. Okay, just use a nice triangle, a nice coordinates. Okay, so from here I have 2, 4, 5, 0.0065 minus, this is 1, 2, 0.00120 divide by x would be 400 minus 1,400. Is that right? 5.3 times. Okay. So my number is a bit off, I think. 0.006, 1, 2, 3. Minus 0.00120 over 400 minus 1,400. Eh, why is the number different now? It's just right. 0.00620. Something wrong. 0.00120. 5 times 10 to the power of minus 6. Is anyone doing this calculation?
Yes.
What did you get for your rate at 0.005?
Not yet.
Not yet. So why am I doing this is because I want to show you that as you increase the concentration by 2, what happens to your rate? Okay, so my number I think is a bit off. Yeah, it's a little bit too big. Times by 2.76. Okay, but still 2.76 is closer to 2 than it is closer to 4. Okay, so times by 2.76. So as I increase the concentration by 2, my rate increases by 2. So that's first order. Okay, I think one of my tangents is not that accurate, right? So this is the second method of finding the order of chromium. You just need two concentrations and two rates. And then you want to look at the relationship as you increase the concentration, what happens to the rate. Okay. So you might get a better number depending on how you draw your tangents.
Is 3.76 times 10 to the power negative 6.
What did you get?
3.76
3.76 times 10 to the power of?
negative 6.
Minus 6. Okay. So in that case, it would be 1.38 times 10 to the power of minus 5. Oops. How about your initial rate, Shakirin? Is it the same?
1.45
Okay.
times 10 to the power negative 5.
Oh, yours is bigger, I think. It's times 3.67. I think you need to change your tangent because it should be the difference between the rate of your second concentration and the first one should be times 2. Okay, because it's first order. If it's times by 4, that means it tells you it's second order, and that is wrong because from the half-life calculation already you saw that it is first order. Okay, right. I'll leave you to do that, the second method, later on because we only have like less than 10 minutes. So I'm just going to finish off this question. Write the rate equation for the reaction and calculate a value for the rate constant. Okay, so write your rate equation. Rate is equals to K times by the concentration of your chromium complex to the power of 1. Okay, now you don't include PR3 because PR3 is 0 order. If you raise the concentration of PR3 to 0, it becomes 1, right? Now, how do you solve this rate? A lot of you got confused with calculating the rate and the rate constant, okay? So this question wants you to calculate the value of rate constant. So that means you want to find K, okay? Now, how do you find rate and concentration? Easy. If you just choose the concentration of 0.01, you find the rate at that particular concentration. Okay, so in this case, depending on your tangent, your rate, because my rate was 1.38 times 10 to the power of minus 5. That's my rate. And my concentration has to be at the tangent or at the gradient, okay, which is 0.01. You can also use the rate here, but your concentration would be 0.005, okay? If you don't like to draw the tangent at the start, you can find the tangent at different concentration, but your concentration must follow that tangent, okay? For example, if I take the rate here, that means my concentration is 0.005. Okay, in this case, I'm going to use the initial rate because that's the easiest, right? Initial rate is 1.38 times 10 to the power of minus 5. How do I know that? Because I draw the tangent and I calculated the gradient, okay? And the concentration is, 0.01, okay? That's one thing. You have to solve for K. The other thing is the units for K. Okay, people still get confused. The unit of rate is always mole per dm cube per square minus 1. Always. It does not depend on what concentration or how many brackets you have here. Okay, so the rate has a unit of mole per dm cube per second square, and that chromium complex has a concentration of mole per dm cube. So when you want to solve K, obviously you would bring this term, the concentration term, to the other side. So you can see that the mole per dm cube cancels out. And that should give you the unit of K, right? State the units of the rate constant. And the last one is the mechanism. You have A, B, C, D. They want you to choose one mechanism which is consistent with the rate equation. So which one do you think is the correct mechanism? You have to look at the rate equation. The species that appears in the rate equation is the same species that appears in the slow rate determining step. So which one is it? A, B, C, or D? Can everyone please try to answer? So which one do you think that agrees with the rate equation? I repeat, the species that appears in the rate equation is the same species that appear in the slow rate determining step. So which mechanism
B.
is that?
D. D.
D. D.
I
D.
receive an answer D. I receive an answer B. Any more? So far, the most common answers are B and D. How about the rest? No more answers?
No.
B or D? The answer is
B.
B. Okay, the reason is because you look at the slow step. And in the slow step, you only have this chromium with 6 carbon monoxide. CrCO6 is in the slow step. So that agrees with the rate equation where you only show CrCO6, okay? The reason why it's not D, because for D, the slow step is CrCO6 and PR3. PR3 does not appear in the rate equation. You can say that it's power to 0, but anything power to 0 is just gone. The term is gone, okay? So the answer is B, and to explain that, you will say that because only CrCO6 is involved in the slow step, which agrees with your rate equation, okay? I repeat, the answer is B because only CrCO6 is involved in the slow step, which agrees with the rate equation. Okay, I repeat, The mechanism is B because only CrCO6 appears in the slow step, which appears with the rate equation. Whatever you see in the rate equation, you must see that same species in the slow step, and only that. Okay. A is automatically cannot because the slow step contains CrCO5, which is a different species, an intermediate. No, that's not intermediate. That's your, yeah, that's an intermediate. Okay. And PR3 is definitely out of the equation already because of the term to the power of 0. Okay. Here for C, same thing. You have CrCO6, 2P, and PR3, which is not the same as the equation. Okay, right. So that is all for today. Question 8. In the next lesson, we will do question 7 again. I will continue marking your paper, but please make sure you read your correction, okay? Otherwise, you'll be making the same mistake again and again. I will text you later the question that you will have to do because tomorrow is a Friday, so I will give you some questions to do for homework, okay?
Okay.
All right. Okay, thank you, everyone. You can go now.
Thank you,
Bye.
Miss.
Okay, thank you,
Assalamualaikum.
Miss.
You're welcome.
Waalaikumsalam.
Thank you, Miss.
You're welcome. Bye.